Good evening, everyone. It's a pleasure having you all here with us within our new webinar today at the Spatial Analysis and Simulation Lab community. We are a research lab. We are a newly established research lab for just 1 year old. And this is our website. We are dealing with research, dealing with space syntax, spatial analysis, computer vision, photogrammetry. We are conducting a lot of webinars related to the spatial analysis or even general discussion about various aspects of architectural elements, urban design elements, landscaping elements. And we are conducting workshops dealing with simulation movement behavior, trying to understand how people move, how vehicles move. It's related to sustainable mobility. And we're discussing evacuation scenarios, tracing urban evolution through time, and using low technology in photogrammetry, trying to document historical buildings. And we have also a branch about simulating tools. We have developed our own tool related to space syntax. We call it Hayes. It's an open source. You can open it and you can play with it. You can even add, download whatever you wish within the Google Colab. And we are doing a little bit, starting some sort of automation. We are doing things, and we are relating things, computer vision with GIS, and which is coming soon. So this is in a nutshell what we are doing. And today, actually, we have a distinguished guest speaker, and she's my previous student, my dear friend and colleague, and I'm so proud of her achievement. And actually, I have a nice long biography, but I'm going to have a short version out of it, and because she really deserves uh, um, all her achievements. Ghina Yamak is a principal facade consultant and a team lead at Zuteri. I don't know if I pronounce it correctly or not, Engineering International, an RIBA chartered member and an affiliated of the Society of Facade Engineering. She has an extensive experience in architecture engineering to deliver complex and innovative projects from concept to completion. In her leading role, Ghena managed design teams, apply deep technical knowledge in materials, facade structure systems, and building codes to deliver innovative and inventive sustainable solutions. Her responsibility also, including business development, client coordination, and quality control over the design and installation of facade systems. She has a lot of high-profile work development across the Gulf region. She led the technical design for a large-scale mixed-use projects in Riyadh, which incorporated the Najadi architecture style while targeting LEED Gold and Mustadam communities accreditation. She also managed the facade design for a business complex in Mazda City that targeted a net zero headquarters building. Her experience including performing technical peer reviews for prestigious projects in NEOM and for other projects as well related to the Saudi's 2030 Design Excellence Vision. A recognized voice in her field, Ghena has contributed to industry publication and in a frequent speaker at key industrial events, including ZEC World of Facades and the Big Five Global Conference, sharing her insights on technological integration and sustainability. I would like you to welcome our dear guest today, Ghina Yamak. Ghina, the floor is yours. And all the comments, please kindly held it at the end. You can just write it through the Q&A below, or after our discussion, we're going to have like an open discussion. And I think it's going to be an interesting one. Ghina, the floor is yours. And please take your time. And we are all happy that you are here with us. Thank you very much for accepting our invitation.
Thank you very much, Professor, and thank you for arranging for this webinar. As I was mentioning, it's my very first webinar, and I'm really happy to be with you on it. So thank you, and for your team for the arrangements. I'll start sharing my screen. Yes, amazing. So again, thank you for hosting me, and it's a great honor to be with you, with your audience, and I really appreciate you and the team organizing this session. So today we will be talking about facades. So it's a Facade Forum, and we will be talking about the science and art of building envelopes. What's behind this beautiful facades that you see when you walk down the street? What are the layers that are behind those beautiful glass or the cladding? Who is involved into that? Who takes those decisions? How are those decisions taken? What are the factors that implies and affect those designs? So we will kind of pencil down the facade engineering or the building envelope of a structure, and we will be diving deeper on a deeper level with what happens and how it happens until that you see it constructed and beautifully standing on the side of the street or in a very famous city. I'll start with comparing a building envelope to our human skin. So I just wanted to give this metaphor to narrow the image or to narrow the explanation of how a building envelope actually works. So you need to think of a building envelope or a facade of a standing structure, same as our body, same as our skin, breathing skin. So we have our core, we have our skeleton and organs, and this core is actually protected and covered by a very big layer of skin, very thick layer, something that is functional, breathable. We also tend to protect this one layer of skin with extra layers of skin for extra protection and extra preservation of this core from the environment around us, from the weather, from the wind, from the rain. So the building facade or the building envelope works in the exact same way. So a building facade is the exterior face or envelope, we can name it, it has too many names, of a structure that actually separates its interior from the outside environment. And when we talk about facade engineering and design, we're really talking about how a building interacts with both its users and the larger built environment. So there are two main subjects or two main things that we focus on when we tend to design any building envelope. The users, whoever is going to live inside this building, and the built envelope, the built environment that the building is located into it. So on the technical side, the facade has to perform. It controls heat, manages solar gain, keeps air and moisture outside, our biggest enemy, the air and the moisture, reduces noise and resists wind, fire, and even seismic forces. Every material, every joint, and every detail matters to ensure durability, efficiency, and the regulation compliance. But facades aren't just about performance, they are the building's identity. And this is where the aesthetic part comes into hand. They define proportions, textures, transparency, and visual character. They help the structure respond to its cultural context and the dialogue with the neighboring buildings. So when we design a facade, we can't only think about the building itself and only what is the intent of having the building, who's going to use it and all that. No, we need to think about the neighboring. We need to think about the microclimate that is around it. A well-designed facade will be integrated seamlessly into the urban fabric. It considers the surrounding streetscape, the scale, the rhythm of the adjacent structures, and the movement and experience of people at the ground level. It can frame views and enhance natural light for public spaces, provide shading, and even influence airflow to the enclosure. They actively shape the city and contribute to sustainability and energy efficiency, and create a sense of place that is both functional and meaningful. So if I want to sum it up, in short, facade design is where engineering, architecture, and urban integration converge, or marry, I will call it, to produce buildings that are safe, efficient, expressive, and truly connected to their environment. And this is what this diagram on the screen is trying to explain, that a building facade comes from a conversion between the architectural art, what the architects are dreaming of and thinking of and wanting to express their language in, and the technical science, the detailing, the performance, the code compliance, the built environment, respect, and everything that comes under the built environment. And all of those are under the umbrella of the built environment technically. So how can we differentiate between what the architects are doing and what facade consultants are doing? What is the architect's role and what is the facade consultant doing or adding value on this job? And why do we need facade specialists? Why can't an architect only do the job and that's it? So when an architect looks at the facade, they will be looking into the architectural design. They will be looking into the expression, the language, the geometry, the orientation, the features that will come into the facade, as I will call it sometimes as an accessory, how they think of it, but how we can translate those features into elements that actually function and benefit the performance of this facade. The material selection, the material color and texture. The architects will be looking into the material. Oh, it's beautiful. We can put it here. We can put it there. But as facade consultants, we will start looking into the material. Okay, is it compliant as per the local codes and regulation? Can we fix it? Is it actually supplied in this market or do we need to import it? Do we have manufacturers for it? Can it be manufactured in this country? How is it? How are we going to fix it? Does it need insulation? Does it need some fire tests? Does it need? Too many questions that will be more and more asked when a decision will be made on a material selection. Modulation design, for example, the architects will be looking into the modulation split. Oh, I want a curtain wall of 3 meters, 4 meters wide, but when we get into the facade engineering, there are some limitation on the glass coating, for example. A high performance glass will have a certain limitation on the width of the facade, okay? I mean, it depends where are you located in this world and what are your capabilities, but I'm referring to our market in the Middle East. So those are the limitations, not the limitations, I would call it the measures that the facade consultants will start looking into it when approaching a design. So when designing a facade, architects and facade engineers often, we approach it from a complementary perspectives. So we complete each other actually. Architects will primarily focus on aesthetic, experience, context and its aspect. They consider the building's identity, proportion, rhythm, materiality, transparency, and how it interacts visually with its surrounding. However, facade engineers, on the other hand, we focus on the technical performance. We start analyzing the structural stability, wind load, seismic resistance, thermal insulation, moisture control, air tightness, acoustic performance. So where is this project located? Do I need to have a high acoustically performance facade or a normal one is okay? How noisy the rooms will be? What is the insulation layer that I need to use? And what is the glass thickness that I need to use for this facade to keep my users content and stable in this room? So we start optimizing the facade to balance energy efficiency, environmental performance, and long-term functionality as well. Longevity of the design is a very important factor. Also, when we start looking into its cost and its operational cost, we will be tackling this point later on the slides. So ultimately, a successful facade will be emerging from the integration of these perspectives where architectural vision and technical precision work together to create a building envelope that is both visually striking and highly performant. So this is just a notion of what architects see and what us as facade consultants see. So it happens a lot that architects will come on, for example, competition stages or very, very early on design stages, and they start testing, how to say, testing the feasibility of this building geometry. Can we do it or not? So they would be presenting very dreamy geometries, like curvy geometries, double curved, on a very high building, in a very high wind area, for example, on an island, like you don't have actually much room to escape from wind and its impact. And discussion starts to happen, but this is what architects will be liking to sell. This is what is getting sold to the developers and to the decision makers, right? Dreamy renders, very optimistic geometries, very challenging geometries. The height is okay, we can tackle the height with the right wind load, but the geometry and how the geometry is playing its role with the wind load and with its surrounding. Is it standing alone, or is it part of an urban context? How are we going to access this tower to actually install the facade? So those are questions that we actually think of from the day one when we receive a render or when we receive a perspective of a complex geometry building. How are we going to build it? Who is going to build it? Do we actually have the skills in the market to design, manufacture, and build it? Do we have the builders on site skilled enough to be able to execute such a geometry? Too many questions that we answer and we try to clarify to the architects and to our developers and clients early on the design. We saw it, we encountered in too many projects that the geometry would change based on the recommendation and based on what we are trying to advise them on. Cost is a major driver when dealing with the construction industry. Cost is always tackled from day one. And whenever we receive a project, we request, okay, that's your visual, but what is your budget? Like how much money do you have to build that facade? Are you actually considering that? And those are the type of multidisciplinary, I would say, coordination layers that happens across the project. So what architects see, beautiful facade, complex geometry. The more complex, the more curves, the more, layers that they have, the better. What we see is what is actually going to be executed on site, the detailing, the installation process, the manufacturing process, the manufacturing source. Is it going to be here in this country, or are we going to import it? The transportation measures, the logistics that will carry those facade elements, are those elements going to be arriving safe to the project location or not? So a very long list of questions that we start questioning when receiving a project, talking about complex geometries and complex projects, and not like the small simple jobs. And on the right hand side, like, this is what we see. When I receive such a building, this is what I see. Okay, you have a curved facade. Do you have a double curved or do you have a single curved? Is it convex or is it concave? Because the coating of the glass will be different. So the manufacturing coating of the glass will be different. So too many questions that really we need to understand and answer before kicking off a project and before saying, okay, this geometry of a building is frozen and we can start now the coordination and the engineering of it. So this is mainly the difference between what architects see and design and what us as facade specialists and consultants see and design. Next, I would like to talk about a very important topic that is occurring in this, is happening in this market, and we are all consultants or engineering consultants are kind of paying the the consequences of this big transition. So we are in the Middle East, we are in a very hot climate, and the vernacular architecture of the Middle East region imposes certain measures for architecture, or for the architectural language, talking about the geometry, material selection, elements and features, talking about small windows, opaque facades, narrow streets, and so on. So when we discuss the transition from vernacular to modern architecture, it's important to see that it is not just an aesthetic evolution, but we need to see it as a fundamental shift in how facades perform, especially in hot climates like the Gulf region. So traditional vernacular buildings were deeply responsive to the environment. Thick mud wall, shaded courtyards, wind towers, where we had clever passive solutions to reduce the heat gain and maximize natural ventilation and provide the comfort without energy-intensive system. Okay, without an energy-intensive system. So these facades were inherently sustainable, responding directly to the extreme sun, high temperature, and seasonal wind pattern. On the other hand, modern architecture in the Gulf is introducing new drivers and challenges. The urban growth, the high-rise towers, iconic designs, and globalized aesthetic meant facades now had to meet much higher technical demands. Tall glass curtain wall, complex geometries, and high-performance cladding systems are visually striking but require careful engineering to address this extreme solar radiation, high ambient temperature, dust, and humidity. So facade engineers must now optimize thermal performance, reduce the cooling loads, and prevent thermal bridging while ensuring that the durability in harsh conditions where materials can degrade quickly. So what we actually did is that we created a problem, and now we are working into solving it on and on over projects. We shifted from vernacular architecture, the architecture language that actually responds to the built environment. We shifted to a very different architectural style that doesn't tackle and it doesn't take into consideration any measure of this climate. And we started resolving. So we put a glass facade, and then we put a very high cooling system in the MEP design. And then the structure needs to have also a certain consideration. We didn't need all that when we had the vernacular architecture, but it's a demand, it's a market demand. It's the demand for high competition of being the best, being the most modern, etc. So to add into this, at the same time, architects are pushing for transparency, daylighting, and the crazy forms, as you can see, creating a need for facades that are both high-performing and visually expressive. Adding into that, sustainability goals, net zero targets, and green building certification that are even making the job further complex, requiring that facade minimize operational energy, right, and embodied carbon, even in region with some of the highest cooling demand in the world. So again, summarizing it is like we shifted from what suits us to a style that it doesn't suit this country. We created the problem, and now us as engineer, we just resolve this same problem over and over on projects. Moving forward to sustainability and the sustainable facades. So in brief, sustainability is no longer a trend. It's actively shaping how we design facades today. With ambitious targets like net zero, we are being pushed to create building envelopes that are highly energy efficient and that minimize operational emission throughout the building's life. It's not just about saving energy, it's about rethinking the material we use and the way we assemble them and how every detail of the facade contributes to overall building performance. So green building certifications like LEED and BREEAM are playing a huge role in this shift. They encourage the use of high-performance facade that not only look good, but also meet strict environment performance standards. On top of that, regulations on embodied carbon are promoting designers and engineers to choose materials that have a lower environmental impact right from the start. So the selection of the material needs to be from the very beginning, consulted by too many parties. Helping reduce the carbon footprint, even more, the building is operational. So what this means for us as facade designers and engineers is that we are now at the forefront of the sustainability architecture. Every decision from material choice, system detailing, and thermal performance to daylighting and ventilation plays a role in creating buildings that are not only functional and aesthetically pleasing, but also responsible and future ready. In short, facades today are much more than a skin of a building. They are a statement of environmental responsibility. Moving forward, again, a notion of when we say a sustainable building, directly maybe we will be thinking of greenery on the roof and greenery on the facade, but it's not the case anymore. So on the right-hand side, you see the ICD Brookfield Place in Dubai, and it's a LEED Platinum building, very pleasant building. It's in the IFC. A very interesting building from its interior, and you see it, it's a full glass. Of course, the cost of that was huge to be able to achieve a LEED Platinum requirements. However, it is required to be modern, being visually very attractive and a very interesting geometry, and at the same time, LEED Platinum certified. So this is where the market really oriented or moving forward to, and this is only because that the ESG requirements and other stakeholders and decision makers are pushing for more and more. Moving forward, we'll be talking also about the sustainability, and so sustainable facade. How far we can achieve when we say sustainable facade? Is it actually 100% achievable? Are we really designing 100% sustainable facades? So when we talk about sustainable buildings, the facade is one of the most important piece of the puzzle. In fact, studies show that up to 60% of a building's energy loss happens through the facade. Okay, so this is a huge amount. It's a 60%, which means it's a huge factor of how much energy a building consumes. On top of that, facade contributes about 25% of the building total embodied carbon. So the material we choose and how we put those together really matters for sustainability. But it's not just about energy and carbon. The facade also controls daylight, ventilation, insulation, and thermal bridging, and it helps keep occupants' comfort while reducing the urban heat island effect. And here is the gulf. The design has to respond to some extreme conditions and intense heat, strong sunlight, high humidity, and dust. That's why we use high performance glass, reflective coating, and other measures to reduce this impact. So when we design a facade, we're really balancing multiple things at once: energy efficiency, carbon reduction, occupant comfort, and durability, all while making sure the building fits its environment. That's why facade engineering is such a critical part of the sustainable architecture. And it's a topic that we see rising more and more into events and more and more into talks with the clients. So moving forward, I want to talk about the cost. I want to talk about the cost because it's a factor that is sort of deciding and driving all of us from engineers to the architect. So the construction cost of a building envelope typically range from 20 to 25% of the total project budget. And this is a big number if you look at it. So, and it's influenced by design complexity, material selection, energy efficient, and local specific conditions. It depends. So what factors actually affect that cost? Mainly the material choice, the facade system complexity, the performance requirement, the height and accessibility of this building, the integration with the structure and MEP. Too many factors that can affect that cost. One of the most important factors, of course, the decision of how much sustainable this building will be. The more sustainable targets that we get, the higher the requirements on the material, the more cost that we will need to consider. So when we talk about cost, we also need to think about the OPEX and the CAPEX. And what is that? Is the capital cost and the operational cost. So CAPEX, or the capital expenses, is the upfront investment. This is everything that goes into the facade at the construction stage, design, material like glass, aluminum, insulation, shading devices, and all those other elements. So, and of course the testing and the commissioning. So now the facade is not a small item. It usually makes up to the 20 to 35% to 25%. However, the OPEX cost, or like the operational cost, is the cost of the running and maintaining the facade through the life of the building. So that means cleaning, maintenance, replacement of ceiling, regular inspections and repair. But the biggest part of the OPEX is the energy, heating and cooling, ventilation, the lighting, all the heavily influenced by the facade. A poorly performing facade can drive energy bills through the roof, with the up to 60% of energy losses happen more. So if we want to talk about the capex and the opex consideration, we can see from the graph that the high performance facade can cost more at the beginning, but its operational cost will be way less than a standard designed facade. So the standard design facade will cost us less at the beginning, but its operational cost will be huge by the end. And this is where the balance is. And I would say that this graph explains the typologies of clients that we work with. Some people are always red, and other clients will say, no, I'm a green, like I will go with the lower operational cost later and pay more now. Very important factor to consider. Later are the risks of the facade design. So what risks are associated with the facade design? So we will be talking about the facade design risks and failure, and what can go wrong, and when it goes wrong, what happens as a consequence. So our biggest enemy in facade design is the water and the moisture ingress. In this market, it's a very big topic, and it's a very, very tricky failure, because the cost of that means a renovation of interiors, cost of sometimes we need to remove the entire facade and put it again. It's not a matter of just fixing a membrane and that's it. A structural and wind load failure, this is another drastic failure that can happen, and we also can see it. You see sometimes that some facade cladding panels are just falling off. And why is that? Is that the design is not well maintaining the consideration of the wind load and at a certain height. Thermal and energy performance issues, and this is mainly associated with the thermal performance and the thermal insulation line of the facade not maintained. It's just disconnected, or maybe it's not there at all. Material durability and compatibility problems. So not all material work together. When we have a rain screen system with a cladding, a substructure, and a subframe, we need to think about those elements, the elements at each layer. Do they actually work together? Are they compatible? Yes or no? We can't just cut and paste whatever is there and assume that it's going to work. Fire and life safety risks. So this is one of the biggest high-ticket items as well, as the fire risk that can be associated mainly with the rain screen systems and with the requirement of spandrel panels with curtain walls. In this country, for example, in Dubai, in the United Arab Emirates, they updated the fire and life safety code in 2018 based on a very big fire that happened in the country due to a rain screen system that started in where the fire started in one floor, and because of the facade cladding system, the entire tower just went on fire. It's a very important and risky topic, because also it puts people's life in danger. Poor construction quality. It's also, we see it a lot. Designs can be perfectly done, but the manufacturing of the systems and the installation of the system can be really, really bad. And this can take us to the failure, bad screwing, bad fixings, bad anchoring, not correct joints, and so on. We're going to see now images of that. Absence of construction QA/QC. So this is when consultants are not on site, where builders are just building and handing over projects, but no one is watching, no one is recording, no one is monitoring what's happening on site. So the absence of a proper QA/QC. So as I was trying to say, that water and humidity is our biggest enemy. It's we always talk about it as like it's funny how we are all scared from a drop of water, because if one drop of water just comes in, it means that the entire facade design needs to be re-looked into it. It needs to be disassembled, re-looked into it, and assembled again. So when we are on site doing a water test for those facades, we would be all very nervous, like we really want this test to pass. So those are images from consequences of bad installation that allows the water in, or allows accumulation of humidity into the glass or around the frame, where there's no insulation, for example, or maybe there is insulation, but it's just that the water barrier is not there, or it's not installed right. So this is what you get. You get fungus, you get really bad conditions. Those images are just examples of bad installation of the facade. So the facade is there. Maybe the facade was designed really well, but the contractor just wanted to not add this layer of pressure cap to the curtain wall, and this will lead eventually to bad performance. It will lead to leaks. It will lead to the curtain wall will not perform the same, of course. On the image on the right, you can see that the transom pressure cap piece is just not aligned. Again, they just decided to do that, or it's just poor installation, or sometimes scraps being there and they just want to install it, or maybe it's just poor installation and not monitored and reviewed well by a consultant later on site with a proper QA/QC. So we encounter a lot of those issues on site, especially with the old buildings, where I would say there wasn't maybe proper system for a consultant to be on site and review the contractor's work and making sure that whatever we delivered as a design is properly done on site. We see it a lot. We see it a lot also in stone facade, where panels are falling, panels are breaking. What's the reason? We go there, we inspect, and sometimes there's absence of fixing. Sometimes some facades are fixed with a mechanical fixing, proper one, and then the rest of the facade is fixed with the wet fixing, almost there hanging. So it's just a poor installation on site. For example, on those pictures, we can see that the window is not aligned at all with the curtain wall, and the frame is just not there. I mean, it can be frameless, yes, but I mean, it's just misaligned and it doesn't close properly with the curtain wall. This will lead us to water leakage for sure, and to air ingress for sure, which will lead eventually as well to what? To humidity, fungus, very bad conditions that can happen on the interior finishing and fit out. Those are just examples as well from the interior, how fungus can go into the into the furniture. This is really a very hot topic in this market, because for example, during the summer in this country, the humidity and the heat is really high and people tend to leave to vacation and so on, and we tend to close our places without AC and leave. So what happens there is the game of the dew point, and the nasty game of the dew point, where the surfaces start to accumulate humidity, and the humidity will start being accumulated behind the levels. You wouldn't see it, but it's just there. So it's just it's a very risky item, and all that is because of a bad installed facade or a bad designed facade. Who knows, like whoever, during the process, something misalignment happened, and the result is this. So this is why one of the mitigation measures that we can do to avoid a bad installation or a bad design or failure in a facade design is a proper multidisciplinary design coordination. So what does that mean? So this means that the architect job is always to overlook all the engineering consultants, and including the facade, but also as facade consultants, it's our responsibility to do our check mark with every consultant. And when I say every consultant, I mean it. I mean every consultant. It means we have to go and to do our coordination with our structural team, with our MEP team, and see what they are accounting for thermal performance. We have to go there and talk to the fire and life safety consultant. We have to make sure that the sustainability consultant is on board, and we have all the performance requirements, acoustics, and the list goes on and on. So we have to do this check mark, and we have to make sure that our packages are very well coordinated. We cannot issue a package and just assume that the facade consultant will be specifying a certain thermal performance, and MEP and sustainability are in a different world. So this is one of the biggest miscoordination and failures that can happen. So early on collaboration is very, very important. I will just talk briefly about simulation and the software. So BIM can, of course, BIM now, everyone work in BIM, and we are all relying on BIM and the clash detection that comes out of BIM to resolve any miscoordination or any clashes that are happening between disciplines. It's a very powerful tool. We rely on it heavily in engineering consultancy. We rely on it heavily during construction to ensure that everything is aligned and everything is in place. Integration of performance requirement, material and system capability, we've mentioned it before, constructability and installation planning. So a method statement should be put in place at the kickoff of the construction stage. So this is post design, where we submitted our design, we're all happy. So who's gonna build that, right? So who's gonna build this building? Who are the people building this building? What is their skills? What did you do? Like, what is your facility, your factory? Where are you located? What are your logistics? How do you store my material? How do you install my material? How do you access my site? So all those questions and conversations we do with the contractors on a post-design stage. And it's very important to make sure that your project is in good hands, in experienced hands, people who actually did the job before. And they do have the knowledge for it. So facades are very critical, and not any contractor can do a proper job in facade, because facade systems tend to have a lot of elements interfacing together, designed together to work together. So any any intervention that is not aligned with what the system can take, it can tend to lead to the failure of the system. So it's not a very fun puzzle game, I would say. It's a very sensitive puzzle game that you really need skilled people to do it. And yeah, maintenance and life cycle consideration is also a high ticket item that we would be questioning with the contractor during post-design stage. Like, how are you planning to maintain this facade, and what is the life cycle consideration of this material? So after 10 years, what will happen to this glass? After 15 years, what will happen to this aluminum? After, I don't know, 20 years, will the insulation stay in place? Will the performance stay in place? So questions that are being discussed with the contractor, also with the clients, to make the right decisions at the right time. Enhanced optimization of the design is always there. We optimize the design from architectural to facades, and there is also a layer of optimization that contractors also do whenever it comes to cost. So whenever it comes to cost, contractors are the heroes of that. They are the best people to know how to cut cost and from where to cut cost, but not always in an efficient way, right? So they would cut cost on a certain material, they would buy the cheapest, but it won't be the right decision at that time. It might be that it will lead to a failure because of the selection of maybe a cheaper material, but it doesn't have the same life cycle as the other. So this is something that I always say, cheaper value engineering is not about picking the cheapest material. It's not about picking the cheapest solution. Value engineering is just speaking itself. The term is speaking itself. It says value engineering is putting value in your solution. So the value in the system is when the system actually lives longer. It performs better over the operational life cycle of the building, and not only at the beginning of the building. So yes, you might be buying a way more expensive system, but this system will live longer than the other system. The other system might fail after 10 years, and you might need to change it again after 10 years and keep doing this on and on. So yeah, so value engineering is something that we tackle a lot. We do it during design, and then we see it happening as well during construction. But during construction it will be happening to a certain limit, but it's excessively being done during the design stage. So this is one of the mitigation measures that we can do to avoid failure of the facade. The other measure, and the other very, very important measure, is the facade commissioning. And why is that? Is because facade commissioning will allow you to actually test the facade design that you've simulated over computer softwares at the beginning of the design. So what does that mean? So we do the building, right? At the beginning of the design, during design stage, we have the building, we have the design, the geometry, the performance, all in, for example, one energy modeling software, where you're plugging all those parameters, U value, shading coefficient, VLT, thermal insulation, MEP requirement, XYZ. So too many parameters, and you run the simulation considering the building location, the weather, the country, the geometry, all that. You run the simulation and you get some results, but do we actually trust those results 100%? How can we test that? Commissioning will tell you if what you designed is okay or not. So facade commissioning is the part that happens during construction, or at the kickoff of the construction, where you start building one small portion of the facade and testing it. What do you mean by testing? I start testing the water, the air infiltration test, the structural load of the facade, the thermal imaging, and where is it leaking, where do we have thermal bridges, the acoustic performance of the glass. And the acoustic performance is maybe not everyone would be very mindful of acoustic, but acoustic is very, very important in a building. The sealant and the joint integrity, and so on. So this is where a team will go on site and start testing your curtain wall, and start testing your opaque facade and cladding, if everything is going well, yes or no, and if what you've designed a year back is actually functioning now. And this is where we say, like, it's the moment of truth. This is the moment of truth where we all stand there and pray that the design is actually compliant, because until that the design stands there, it goes through too many stages. So as I mentioned, it goes through the contractor, the cut sheets, it goes through the manufacturing, the assembly, the installation on site, and so on. So too many hands are dealing with this design until that it's built. So this is why at some point in this part of the world, we are encouraging more and more the modular design, because the modular design, you can highly control the quality of the system off-site. So you're assembling in a factory. In a factory, you can have better eyes reviewing and monitoring what's happening, rather than being on site with laborers and following the laborers in this weather. So is just highly maintained in a factory and transported to be installed as one piece on site, which will create a better QA/QC process, which will create a more confidence that, okay, the system is actually tested and it's actually done as the book. But again, the moment of truth, the testing is the only thing that can actually say if this facade system is succeeding or not. It happens a lot. We saw leaks. Okay, what can we do? When there is a water leak, we just disassemble, we detect where is the leaking happening, we try to rectify and install again. So too many tests can happen. The coolest are the fire tests. So just a background on fire tests. So some systems are tested and approved, okay? And we or tested and approved with the trusted third party, compliant with the regulation, and those can be used. But sometimes the project is very iconic, the geometry is very iconic, and we need to redesign it. We need to redesign the facade system and propose a brand new facade system. So when this happens, when this case happens, the facade system needs to go down the road of being tested. So this is when they design the facade, they manufacture, they assemble it, and they take it to a testing agency, and they actually put fire on the facade and start counting, okay, for how many hours this facade can take. Is it 1 hour rated, 2 hours rated, and so on. So fire tests are one of the coolest, I would say. Wind and air tightness is also one of the cool facade tests that can be done with the rain. Water test is also something that can be done off-site and on-site. Usually we do it on site. When the facade is installed, we go with certain water hose, and we go on a cradle, and we start passing the water through the aluminum frames to make sure that there's no leak, there's no water coming inside. And if there is a snag, or if there is a water leak, we will need to rectify, we will need to detect and rectify that. So I will leave it there. So I hope it was nice. So I just wanted to tell everyone that next time you admire a stunning facade, just remember somewhere there's someone like me. A team of consultants is probably tearing their hair out. It's a very cool process, facade engineering, and it's a very cool journey we do with every client, with every design. But it's very complex, and because it overlays too many subjects and too many layers, the checkpoints are too many, and the skipping one or avoiding, or not avoiding, like skipping one or not paying attention to all those points equally can lead to a not very successful facade design. So we are in a continuous challenge with architects, with clients, making them accept the code compliance, the standards that we need to preserve. It doesn't happen always that they are happy about what the code wants, or what the regulation are asking for, or what does the performance require to achieve it. They would be doing some changes in the geometry. They will need maybe to pay a bit more, but we try always to explain that this is always better for the building performance on the operational side, and on the longevity of your project. So I'll leave it there. And yeah, I'm happy to take questions.
Thank you very much, Rena, for this really valuable, informative presentation, and you have opened the door to new ideas, new thoughts. And I remember 10 years ago, or 8 to 10 years ago, when we are discussing about, okay, what's meant by facade engineering, or what actually they are doing. And I know the story, but I hope my future students who are going to see this webinar, because it's really it's needed. How do you think the transition between being an architect and go to a field which is merely for electromechanical engineering students, or graduates? So how did you see the transition? Was it easy? How the story was there? And we are eager to hear it, because I think it's going to benefit a lot of new fresh graduates who just searching for a new path to their profession practice.
It's really iconic, I would call it. So I will give you a bit of brief of my background. So I come from a manufacturing family business. So it's something that I've been raised on, right? So we have a family business in stainless steel manufacturing, and I've been there shadowing my father, I would say from the age of 12. Yeah, I remember spending my summers at my father's factory, playing around with pieces of stainless steel. What's this? This is welding. This is a screw. This is an anchor. And I mean, it's just the knowledge and the passion, how you build your passion and how you build your interest, I would say. It's very important for you to know what you like and what is your passion, what drives you, and what makes you really wake up every day to go to work. Is very important. So being in architecture was a given for me. It was something that is just meant to be in architecture. And I went into the domain very convinced that architecture is the best domain for me, and I really want to excel into it. But I started exploring more my passion, I would say, from the second, third year, where we started looking into the details of things, where where the construction topic started to be a more consequent subject and topic, and where we started being asked, how are you going to build it? What material are you going to use? So those questions weren't too far from me, because it was the project at every project I used to work with my father. Like, okay, how are we going to build this piece? How are we going to build this design? How are we going? It's something that I've been raised into it, like being asked the question and going to the factory and start testing and resolving and actually building the things and going and installing it. So the process was there, not on a building scale, on a manufacturing scale, but it's just the mindset and the thinking that you build throughout the years. So I believe I knew from my third year that I'm not going to be a pure architectural designer. I knew that I will be picking a specialty. I want a technical specialty and not a dreamy designing sort of an architect. And architects are types and characters, and it's just okay to pick what you want to be, right? So I remember my graduation project even had a lot of facades. I worked on a lot of facades on my graduation year, and I still, at that time, I didn't know that I will be specialized in facade engineering. My master's degree was the turning point. It was a huge turning point. So my master's degree was a topic proposed by Professor Nabil Muharib. I still remember the story. Like, we finished the presentation of the bachelor, like the bachelor project, and we had that small discussion after, like, let's do masters. Yes, let's do masters. Let's do a topic about facade engineering. I was like, yes, let's do a topic about facade engineering. And it was a design and build. And this is where I was able to, this is why I mentioned the marriage between the architectural design and the technicality at the very first start, because this is how I started. Like, I wanted to do an architectural design, and I wanted I knew at the back of my mind that I will be manufacturing this at the same factory I've been working on, like, for all those years. So that was the turning point. That was where it opened my eyes that there is a domain called facade engineering. But this is also, it goes down to your curiosity and how much you want to explore. So we finished the project. It was a 1:1 scale facade design of
I remember.
metal and
Yeah.
PV panel. It was a 5 meters by 3 meters. It was a huge piece of facades installed, and seeing it, that, wow, we designed that and it's actually working, and we manufactured that and installed it and it's working. It's like, it was operational, kinetic, beautiful facade, beautiful project. And this is where I started from. I was like, okay, I'm doing that. Like, I have the technical background, I have the manufacturing and all this interest, and I love it. Like, I love seeing things getting designed and then created and installed. And I followed my passion. I just followed it, and I started asking more and exploring more into the domain. And till today, the facade industry is still considered as a young industry. It's not like the structural or the MEP or any other industry. It's a very young industry. The peers of this industry are very counted, and where you can learn and where you can go are very, very selected, and which made my research easier, because it's a niche and I was able to go into the niche and start from there. So I've been always working 8 years now, working into the facade industry, and I'm very happy about it. Now, when I sit with architects, and I always say to myself, I'm really glad I picked a specialty. And this is what I always say to grads, and this is what I always say to architectural students whenever I have the chance, whenever I meet someone. I tell them, look into a specialty. You are good. Architecture is a very big umbrella, but you should be good at one thing, and be good at that one thing and be known in being good at that one thing, better of like, grabbing everything in one hand. So it's good. It's a matter of research and curiosity and testing yourself. What do you like or what you don't like? Other people, if you put them in front of a detail or asking them technical or how it's going to be constructed, what material are you going to use, they will be freaking out. They like the design, they like the renders and all that, and that's fine. That's your passion. Follow it. But it's just give yourself the chance to explore. And exploring can't be by just by seeing images on the internet. Get your hands dirty and go into the domain. Go talk to people. Go to factories. Go to sites. Like, just push yourself as much as you can. And this is where you start exploring what do you really like. Like, whenever I have a factory visit now with any of the suppliers, I'll be like at the top of the mountain. I'm like so happy I'm going to a factory. But it's just translates my background, right? And same to any other thing. So sustainability now is a niche, acoustic is a niche, fire and life safety is a very important topic, and architects can be specialized in that. Code compliance, like, it's too many topics. I can sit and the list is really, really very long, being specialist in one domain. But in my opinion, architects needs to be specialist like in one domain. It's nice to be the designer and all that, but you will feel your value in the market way more when you are a specialist in a topic that people will call you in for this specific service. So it's just where you place yourself, I would say. And yeah, passion and curiosity, I would say this is what will drive grads from the school, like from classes to the industry, more than anything else.
Well said, thank you. So I'm going to
Thank
open
you.
the floor for any further questions. If you wish to write them, if you wish to raise your hand. Yes, Dr. Randa, please.
Thank you so much, Engineering Ghina, for this outstanding presentation. It was very interesting and very insightful. You shared a lot of interesting information about facade consultants and facade engineers. And also, it was very interesting to share your passion about technicality. I have one question about you already mentioned the transformation between vernacular architecture and modern architecture, and how it caused maybe some problems, especially related to energy consumption and maybe in the era of climate change and overheating. Can you share more about the tools, methods, or research type do you consider while design in terms of climate change or mitigating future climate change? Thank you again. Thank you.
Sure. So the main tool that will be applied is the energy simulation or and the energy simulation tools for the building. So this is where they plug, as I mentioned, and it's more onto the sustainability people. But I know that because we do have the simulation running as well whenever daylighting, layer analysis, shading analysis are required. So it's mainly about energy modeling. And the energy modeling, as I mentioned, is too many layers considering the building scale, considering the building geometry. It's a platform where they just plug that project and start adding the performance layers into it and run the simulation on and on over the project design cycle. But going back to the vernacular and the modern and that transition, as I mentioned, it's really the fact that we shifted from what is good for us to what is trendy and what looks nice without considering really what benefits our climate. We are in the Middle East and the heat is a very big problem. We are using on those towers mainly and majorly the glass, which is a very high transitional and the metals, which is the aluminium, which also transfers the energy and the heat in a very, very fast manner. Yet we are still using it, we are still applying it because of strengths and architectural language requirement, the direction of globalization, and not have one architectural language into it, but using more of a universal language into the cities, and this is keeping us, and this is like this is what forcing or putting the challenges in front of us. However, one of the very important projects and unique projects that I encountered are the Daraiya in Riyadh, as the Daraiya Gate, the Riyadh Gate, we call it, like the Daraiya Gate. It's a very huge development in Riyadh, and their main target is to revive the Adobe construction and to apply the sun-dried Adobe construction into the modern buildings again. And you have no idea the challenges that we've been through adapting this material with the modern structures. So you have a very old skin, and it was a requirement. We had to use the sun-dried bricks, like the very old bricks that they used to do. And we had to use the Adobe render, which is a 50 millimeter of Adobe render on the rain screen facade. But behind that facade, you have the modern concrete structure, the modern MEP, everything is modern, but the building envelope. And merging those two was a huge challenge. Like Adobe render wouldn't stick on concrete. It would just fall because it's just not consistent. You have a breathable material and you have the concrete, nothing breathable in concrete. So they just don't merge together. You need mud on mud to merge together and stand in there. They wouldn't just stand in there. And it's not a matter of building a modern building and then just putting the vernacular layer on it. So it was a big challenge. Us in 2025 dealing with a material that's been used for thousands of years. We weren't able to, like at the beginning, of course, we weren't able to find a standard system for it. We had to recreate everything to merge that iconic vernacular facade to be consistent and interfacing well with the modern structure. So energy modeling, yes, was helpful. Yes, of course, was helpful. But as I'm trying to say, simulation tools can be very helpful at the very beginning of the design, but what puts you into test really is the site and the test on site. Because on simulation, everything was okay. The design was fine, but then they did only the mock-up, I remember. And we started seeing like things that, oh my God, is this really happening? Like the Adobe render just went off the facade. What simulation tool will show you that? So it's just parameters and think that only site and only test on site and witnessing the installation process and witnessing how this building after installation is interacting with its environment. Simulation tools can show you that, but the accuracy of those tools to me are still there's a big question mark on it. Yes, BIM, I would say BIM, it's a modeling platform. We are all seeing what's being modeled, what is being interfaced together and all that. It's for geometry, facilitating, like avoiding clashes, all that. That's cool, that's amazing. But energy modeling is happening anyway. I mean, you cannot apply to any LEED or BREEAM certificates without submitting an energy model that is proving that this building is a net zero building. But let's take that certificate and check that building 5 years after, not 10 years, just 5 years after. And let's check again. Are your parameters really working? Is your energy model really working? I don't know. I mean, it could be, but yeah, this is how we try to tackle it, and this is how we try to balance it. And one of the projects that put us into test really is this Najdi project, that we had to innovate a traditional facade to be integrated into a modern substructure. So that wasn't easy. The project was Mustadam LEED. They had very high sustainability requirement. We ended up with facade section of 600 millimeters. This is 60 centimeters of facade. This is for GFA. It's a nightmare for any developer having a very thick facade, but this is just because they insisted on having like the Adobe bricks with the layer of render, and then we had to design the rest in a modern method. In old days, you would have only the Adobe, right? You would only have the Adobe in one bulk, yes, and on a certain height, but you would have only the Adobe. But because it's a modern requirement, you will need the substructure, you will need the concrete, you will need the MEP and all that. And that was the real test into the capabilities and how you can merge those two.
Thank you so much.
Thank you. Dr. Dina Khater, if you wish to address your question.
Yes, good evening. Thank you for the presentation, which is actually building our opportunity for this specialty. My question actually is regarding the contracts for some projects in Egypt and Saudi Arabia. We often face the issue that facade designs contain details requiring the involvement of a facade consultant. However, the client usually responds that this consultant was neither included in the contract nor the original audit of the project. How can we clearly explain the distinction between the role of the architect and the facade consultant, especially when we are going to address the impact on the overall cost that since the facade consultant's fees were not originally considered?
So requirements and sustainability requirements and what can the building achieve, this is a subject or a decision that should be made mainly by the client and by the sustainability consultant. So it's not something that the facade consultant will be deciding on. We will need to be the facilitators of the design that complies with this requirement. So how do they get to decide on having building with such a certification? It can be too many parameters. It can be that the developer actually cares about sustainability and they actually have a pattern of building sustainable buildings, well-maintained buildings. They want to communicate to the built environment. They want to preserve the energy consumption and all that. A lot of times happens that it can be something more related to trends. Like we want to follow the trends and we want to be the developers who are known to, we built the first net zero, we built the first LEED platinum, we built the first, and we see it a lot in our market, but of course with intentions of saving the energy and with intentions of boosting the capabilities towards working on a more sustainable designs and more sustainable solutions. But of course it comes at a cost. So having a sustainable net zero facade will cost you way higher than having a standard facade that is compliant with the local codes and regulation. So how can we control that? It's not something that we control. Those are decisions that are made by higher stakeholders, and us as consultants, we just need to translate whatever they are sort of putting in the agenda into the construction process. So however, it happens on a lot of times that we tell, like, for example, if you want to go net zero, this is the facade cost, and those are the materials that you want to use. For example, some architects will come with materials that wouldn't help much the agenda of the sustainability, yet they want that, they want to boost it and they want to use it. And this is where debate starts to happen, that, okay, prove to me that your material can be applied. Does it help the agenda that you are following? I don't know, submit EPDs, submit something that help more on the translation of this sustainable practice. But it's not something mainly that we can control or we can decide on as a final decision. Is something that clients mainly and developers, as I mentioned, higher stakeholders. So for example, again, going back to the Daraya, it is decided on the Daraya that the entire development, so the entire master plan is a LEED gold, I think, or Saddam gold. So it's the entire master plan. So each building will have to fall under this criteria, nothing less than that. Maybe higher, yes, but nothing less than that. So this is an upper management sort of decisions that they take. prior the kickoff of the project, and it has an influence on how you are marketing your project, to whom you are communicating your project, who is your audience, who are you calling to buy and live in those apartments. So it's always targeting a certain section of audience, and when you are designing those sort of buildings, you are targeting certain people to put their money on apartments or offices or whatever. People who have the same mindset, who would pay for sustainability, who would pay for being in a sustainable office and caring about the users' health and mental health and all that. So it's just, I think the question can be answered on and on, but mainly it's really a decision that is done by higher stakeholders, and we are only, I would call it, the facilitators of those agendas. And the facilitator meaning the coordination with the multidisciplinary, and the importance of coordination with the multidisciplinary engineering team, because if anyone misses anything down the road of the design, this will appear in construction, and when it appears in construction, is usually too late, and rectifying that is usually too late, and consequences can happen, cost consequences can happen. Teams can be like questions, like it's just too many I mean, it's just you just can't miss. You just need to work as the agenda is saying and deliver the design as the brief is saying. And this is when you be called as a consultant who delivered a successful design. You can have your opinion, you can have your recommendation, of course, when it comes to technicality and all that, you can change some of that, but it always need to fall under the umbrella. If they said LEED Gold, we are all going LEED Gold. There's no one should negotiate that until that the cost comes, and tell the client, Mr. Client, you need to pay 40% more to get LEED Gold. And this is when Mr. Client will tell you, oh, maybe I would accept something a bit less. And this is where the agenda will be different a bit.
Thank you.
Right, thank you.
Thank you. Maybe we can have one last question. Dr. Adham Salama. Dr.
Yes.
Adham, we worked together 20 years ago, right?
Yes,
it's
20
nice.
years ago.
Yes,
And
it's nice to see you
really,
here.
I don't have a question, but I would like to thank you after this year that you invited me for such exciting webinar.
It's a pleasure.
And let me tell Ghina, I believe.
Ghina.
Yeah.
Correct.
I worked in 3 projects in Diriyah. By the way, okay? So I understand every word you are saying. I understand how are they strict in not only LEED certificate but also Mustadam certificate. Mustadam certificate is the local LEED certificate from National Housing Company in Saudi Arabia, and also now, because I'm working in an engineering firm, consultancy firm, yes, I fully agree with every word you said, okay, in this presentation. Now, facade engineering is a separate discipline in each consultancy firm in Saudi Arabia nowadays. Okay, usually in the past, facade was used to be handled by architects. Now it's really separate disciplines who is coordinating with MEP, with sustainability, with also value engineering, as you mentioned. It's really now it's a completely a separate discipline. I'm away from the Egyptian market for a long time ago. I'm not sure how they are handling now facade engineering in Egypt. But let me add something, because this is my specialty now. Now, what supports all this life cycle or this story, okay, is something called project management offices. Okay, project management offices, and the area, they have PMO, and they have as well different PMCs, project management consultancy firms.
Yeah.
Okay, yeah, and why they are succeeding? Because they are managing the whole life cycle of the project, starting from feasibility study and the decision to go or not to go. And from the early beginning, they have identifying what is the budget for this project, and they are monitoring this budget along the life cycle of the project. In addition to design stage, and they are managing the procurement of having the right subconsult, the right contractors and subcontractors on board. And also there is now currently there is an overlap between design stage and construction stage. And as you mentioned, yeah, they are preparing mock-ups for certain areas to test the design and to test the materials and to test everything before proceeding in completing the construction and the finishes. For sure, there is testing and commissioning before handing over to the end user. Really, I would like to thank you for this. Really, it's a very exciting presentation. It touched my daily life. Okay, and again, I would like to thank Dr. Nabil for inviting me for this exciting webinar, and I hope to join any future webinars, inshallah. Thank you.
Thank you.
Thank
It's
you very
always a
much.
pleasure. It's always a pleasure having you with us here. Thank you, Dr.
Yeah,
Adel.
thank you.
Thank you.
And actually, I don't want to leave the webinar, and I'm really, it's really exciting and really interesting topic. And thank you, Rina, very much for elaborating more about the topic and opening the floor to a new path for our fresh graduates to select different issues. We don't need all to be architect designers, because I think in the near future, AI will going to perform some of our work. Yeah, and that's why I'm always telling my students that you need to be an architect plus, architect with something else. So plus what? It's up to you, of course. Plus being a programmer, plus being a facade designer, plus being a specialty. You have mentioned this as well in your presentation. So it's not being a pure architect, because like 1% of all architects are the architects right now, and the rest, they are architects, urban designers, landscapers, a lot of specialities in addition to subspecialties which emerged, recently, including new technologies and all of these stuff issues. So, do you have any final words before we end this webinar?
Yeah, it's I just touching base on artificial intelligence and where are we going. It's we are seeing it in the market already. So a lot of architects that we are working with on projects that they are actually getting built and designed, relying heavily on artificial intelligence, especially when creating CGIs and the competition stages and all that. So competition stage when an architect is just sketching, right? Like sitting and sketching and creating, but it's not the case anymore. Like they just plug certain wording, there's certain criteria for those softwares, and they are creating and recreating the buildings, and too many options are there with way less time and way less effort. So you really need to question where is architecture going. So of course we always need the human touch into it, but the tools are aggressively involved into the market now, and we are seeing it in architectural firms a lot. In engineering firms, we are seeing it through computational design and the programming and the simulation of that. It's helping a lot. It's advancing the design process and results a lot. However, in architecture, as pure design and architecture, it's scary the amount of reliance on artificial intelligence today, and how far it's going. Replacing architects 100%, not sure about that. You still need a human being to design a space where a human being will be living in. But yeah, it will require less amount of people working in the sector, maybe over years, because instead of 10 designers, we might require maybe only 3.
Mhm.
So it's just, yeah, picking a specialty is very good. And you will always be an architect. So there's no regret into this. Thank you very much, Doctor, for Professor, for hosting me. It was a real pleasure. And I'm really happy I joined you on this webinar. Thank you very much for you and for the team organizing it.
Thank you very much for accepting our invitation. I'm so proud of you and your achievements. It's really, this is why we teach. We see our students become our friends and our colleagues, and really, really, we are, yani, I'm so proud of you. So
Thank you.
it's a pleasure having you here today with us, and thanks for all the participants being here with us today. And the webinar for like an hour and a half. It's an exceptional. It means it's an interesting topic. So thanks for everyone. Thanks for my team. Thanks, Ghina, and thanks for all participants. And see you in our next webinars. Thank you very much. And we're going to post the record, of course, after the consent of Ghina, into our website, so you can see it again or share it with others. Thank you, and see you on next webinars.
Thank you very much. Thank you. Bye-bye.
Bye-bye.
Bye.